So here we go, we're going to prove the alternate segment theorem. Hopefully you know the alternate segment theorem. If you don't, do check out my earlier video which talks about all the circle theorems, including this one. But very quickly, I do need to say what the alternate segment theorem is to show you the proof. So basically the alternate segment theorem says if you've got a tangent and you've got a triangle coming out at this point where the tangent meets the circle, then this angle between the tangent and the triangle, this angle that I labelled n, is equal to the angle on the opposite corner of that triangle. So when I say the opposite corner, here's the angle n that we start off with, is touching this side AC of the triangle, and the opposite side of that triangle, this triangle ABC, is this corner, and according to the alternate segment theorem, therefore this angle is equal to that angle because it's on the opposite corner. Let's prove it. Okay, so let's start with the general situation for any alternate segment theorem, which is a tangent and a triangle coming out of this point. Then you draw a couple of extra lines, and it'll make sense in a second. First of all, you draw two lines to each of these corners from the center O. So draw a line to there, to A, which is one corner of the triangle, and another one to C. And the reason for that is we're going to basically make an isosceles triangle. How is it an isosceles triangle? Well, that's a radius because it's from the center to the edge, and so is that. So these lengths are equal, and you've made an isosceles triangle because this is a triangle where two lengths are equal, and if two lengths are equal, then two angles are equal. These double lines mean that, you know, those angles are equal, right? So that's going to come in useful very soon. But even before that comes into use, look at this. If you've got a line from the center, basically if you've got a radius here and it meets the tangent, guess what? A radius and a tangent meet at 90 degrees. So that means these two have to add to 90. We've already said this angle here is n, so this one has got to be 90 minus n because they both add to 90. So we called it 90 minus n. And this is where it very quickly builds up to this. So we know that's 90 minus n. Now earlier on we made a right angle triangle here, and you said, how do you know it's a right angle triangle? We just said it was a line, and we assume it's 90 degrees, and if that's 90 degrees, then that's got to be 90 degrees because that's a straight line. That's all. Okay, it's not impossible to have a right angle triangle. We're saying if it is a right angle triangle, which you can certainly make, then that would be 90. And then what would this bit be? Now I've written n there already, but again I'm not assuming it's n. I'm going to show you that it ends up being n just by the fact that this is 90 minus n and this is 90. So how do you know that's n? Can you guess? Well, this is a triangle, so all the angles add up to 180 degrees. So to get this angle, you do 180 minus this 90 minus this 90 minus n, like I've just written here. So 180 minus 90 minus 90 minus n, this is one angle, so I had to put it in a bracket. And it's very important I put in a bracket, otherwise all sorts of stuff goes wrong, like I'm going to use minus minus n. That's very important in a second. So anyway, let's do it. 180 minus 90 minus 90 minus n. This is what this is saying. So to work out this angle, 180 minus this minus that, or I said the other way around, that minus that minus that. Okay, anyway, so let's do it. So 180 take away 90, take away 90 is 0, and then take away minus n, minus minus n is positive n. So the only thing you got left is n. So I've just shown you that this angle has to be n. Now, since we said this angle is equal to this angle, that means obviously that's 90 minus n. We already said that's 90 for a good reason because it's a straight line, so those two both have to be 90 if that one starts off as being 90. So everything's the same, so that's going to be the same as well. For the same reason that's n, that's got to be n because all the angles add to 180, right? Anyway, now we've got to a situation where we've got an angle at the center which is 2n. This n and that n make 2n. Can you see what's going to come up next? Another circle theorem, which is the angle at the center is twice the angle at the circumference. So if this is 2n, this is going to be half of 2n, and half of 2n is of course n. So we've just shown that basically this is n, given that we started off calling this n. So it's basically saying whatever this angle is, so is that angle. It's going to be the same angle, and we've proved it. That's the alternate segment theorem. Now, of course, you can pause the video, read through this. It's just saying the same thing I've just said. I'm going to read it through very quickly. TAC is n, right? That's the way I started. So CAO, this angle here, is 90 minus n. Because, why? Because radius and tangent meet at 90 degrees. Now all this stuff I've written it because I want to show you how you could, you don't have to do it exactly like this, but this is how you could write in an exam. You want to write in a very short way, and you don't want to go overboard explaining too much. Like over here I say angle at the center is twice the angle at the circumference, therefore this is 2n means that is n. I don't need to say more than that. I don't know what else I could say really, but you don't need to say too much. It's very important just to say just enough, because the people who are marking your exam, they're mathematicians, they get it. You don't have to explain too much. So yeah, and of course I've gone through this bit already, and I've said it's isosceles. So if this ACO is 90 minus n because of that. See, like I didn't say I didn't say which other angle is also 90 minus n. I just said you got an isosceles triangle, therefore that's 90 minus n. I didn't say since that is 90 minus n, therefore that's 90 minus n. That's going over the top. Just say just enough. Save yourself some time. You don't need to go into too much detail, because as I said, the examiners are mathematicians.